Hey guys! Alright, so today I'm going to teach you how to do yet another gravitation problem. I know I've done 2 already, but I'm good at gravity, so we'll stick to that. Alright, so this problem is going to be from 1995, and it's a third mechanics question. And again, I'll show you the picture, I'll read it, and I drew my own picture as well, okay? Alright, so 2 stars, A and B, are in circular orbits of radii RA and RB, respectively, about their common center of mass at point P as shown above. Each star has the same period of revolution t. Determine expressions for the following 3 quantities in terms of RA, RB, t, and fundamental constants, okay? Alright, so this is the picture. I just need to make sure. Okay, that's the picture. And here's my own version of it. It's a lot bigger. I hope. My circles, again, are not really that great, but it's the best I could do for now, okay? Alright, so for A, they want us to find the centripetal acceleration of star A. So that would be right here or right here, depending on what picture you would like to choose, okay? Alright, so for A, let's go to sum of the forces because it's our reliable friend. We should always jump to that first. If we can't use it, then we move on. Alright, so the sum of force is going to be equal to the mass times the acceleration. And since it's a centripetal force, we can set that equal to mv squared over r. Okay? So that's our general formula. And so we know that the velocity at A is going to be, we'll name it v of A. Okay? Alright, and since the masses are going to be the same, let's just cancel them out right there. Alright, so the thing is, we have an issue because we don't know v sub A, which is the velocity of the star. But we know that velocity is going to be equal to distance divided by time, right? Right there. So the distance, because it's a circle, is going to be equal to 2 pi r, which is the circumference, divided by the period, which is the time it takes to complete 1 revolution, alright? So we are going to do the centripetal acceleration, so A sub c is going to be equal to 2 pi r over t squared divided by r. So that's what we have so far. And so basically when you just do that out, you're going to end up with 4 pi squared times ra over t squared. So basically, that's what you have. I'm sorry. That's a 4. Mark is not erasable, so this isn't working for me. Anyways, so what you're going to, the centripetal acceleration that we need for part A is going to be equal to 4 pi squared times the radius of A, which is right here. This is the radius, divided by the period squared, okay? Alright, now on to part B. Part B, they want the mass of MB of star B. So over here, they want the mass of the star that's here, alright? So again, we're going to jump to sum of the forces. Sorry. Okay. The sum of the forces is going to be equal to F is going to be equal to MA, which again is going to be equal to MB squared over R. And yet again, we are allowed to cancel our m's because they're constant on both sides of the equation. So there you can see? Alright, there you go. Okay, but we know that the centripetal force is going to be equal to the force of gravity. And that is going to be equal to g times the mass of the Earth times the mass of whatever object that's rotating, rotating about Earth, and the separation distance squared. So basically, that is going to be equal to g times ma times mb, which are the 2 masses, divided by the radius of A plus the radius of B squared. And then when we do that, we're going to set that equal to the mv squared over r, okay? Because the centripetal force is equal to the force of gravity. And you have to remember that for all the v's, we have to do the distance, which is the circumference, divided by the period, alright? So you set that equal and you get m of a times 4 pi squared RA over t squared is going to be equal to g times m of a, m of b over RA plus RB squared. There we go. So that is going to be our equation. And so now using algebra, we just want to solve for MB, which is right up here. Okay? So when we follow through with that, we get MB is going to be equal to 4 pi squared times radius of A times the radius of A plus the radius of B squared all over G times T squared. And so there we go. In terms of everything that we were given and the fundamental constants, that is going to be equal to the mass of B. Now, for part C, they're asking for the mass of A, the mass MA of the star A. So instead of going through this whole process with switching all the M's and B's, we should use our logic and just figure out that the MA is going to be equal to, again, 4 pi squared, but this time times the radius of B times RA plus RB squared, all over, again, GT squared. So basically, the only thing that is switched is this R, this radius, because both should be the same since it's a circular orbit, all right? All right. So now we move on to D. D says, determine the expression for the following quantities in terms of MA, MB, RA, RB, T, and fundamental constants. So basically the same as before, okay? So D is the moment of inertia of the two-star system about its center of mass. So the moment of inertia is defined as the sum of all the masses times all the radiuses, well, distances squared. All right? So here it's going to be equal to, the moment of inertia of the star A plus the moment of inertia of star B. Okay? Because that's the total. And so it would be MA times RA squared plus MB times RB squared. And, well, that's actually just it. And that's the total moment of inertia for the entire system, okay? Alright, simple enough? I think so. Now on to E, it's the last part. And it says, they want us to find the angular momentum of the system about the center of mass. Alright, so the total angular momentum is going to be equal to the momentum of A plus the angular momentum of B. To find the total of anything, you're just going to add up that quantity of each of its parts, okay? Alright. So the angular momentum is defined as M times R cross V. Okay? Alright, so we're going to take the angular momentum at A is going to be equal to the mass of A times the velocity at A, but we have to do the circumference divided by the period. So it's going to be 2 pi RA over T. And that is going to be times, again, RA, because that's M times V times R, okay? And then we're going to take the angular momentum for B, which is the same thing. It's going to be MB times 2 pi RB over T times RB. So basically, when you clean that up, you can take out the 2 pi over T, and you're left with MARA squared plus MBRB squared. And that, my friends, I don't know if you can see it right there, is the total angular momentum for the centum about the center of mass for the system, okay? And so we finished A, B, C, and D, and that means we're done with this problem, and that means we're done with this video. Alright, so I hope I've been somewhat of a help, and if you have any questions, let me know, alright? Have a great day, everybody. Bye!